Dear listeners, on the occasion of Air Traffic Engineers Day, we will bring you a special talk on Air Traffic Engineers are Pillars of the Aviation by Dr. Chilaka Mahesh, Director of Airport Authority of India, Kalaburagi.
Dear All India Radio listeners and my dear Air Traffic Safety Electronics Engineers, first my best wishes on the occasion of International Air Traffic Safety Electronics Engineers Day. Today we are celebrating the International ATSAP Day worldwide to emphasize and spotlight the silent task performed by our dedicated members to ensure a dependable and worthy service in the maintenance of safe air traffic in the region. On this day, we are not just looking back, we are also looking at the challenges ahead. The few countries of air traffic electronics engineers held a first meeting in Brussels on the 12th November of 1971. Then subsequently 1972, the International Federation of Air Traffic Safety Electronic Association was set up with the object of promoting, maintaining the stature of the air traffic safety electronic personnels on worldwide basis. In 2015, International Federation of Air Traffic Safety Electronics Association declared 12th November as International Air Traffic Safety Electronics Engineers Day. This is a day to celebrate all the achievements air traffic control electronics personnel have made over the years and their contribution to safer skies around the world. The very first question we want to know is, why do you want to celebrate Air Traffic Safety Electronics Day? Before jumping into Air Traffic Safety Electronics Day, let us first know who all ATSAPs are and their roles in aviation, in particular in air traffic service. When one thinks about air travel, it comes to one's mind about the image of air traffic control in the tower of an airport and probably the pilot in the aircraft. However, the air traffic control system is much more complex than that. A pilot operates an aircraft to transport people and goods. The controller directs the aircraft and maintains a safe distance between them. The operation of these two systems depends on other system, that is the CNS ATM systems. These systems are managed by air traffic safety electronics engineers. The CNS ATM systems in the air traffic service can be seen as the central nervous system of the human body. As the central nervous system is so critical for the functioning of human beings, in the same way, the CNS and ATM systems functioning are also critical for air traffic services. Any abnormality in CNS ATM systems will harm the functioning of air traffic services. However, the CNS is an amalgamation of three elements: communication, navigation, and surveillance systems. The communication system establishes a communication link between the pilot and controller, where the navigation system assists the pilots in flying from one airport to another. Navigation systems help both the pilots and controller determine the aircraft's position relative to the ground and the aircraft. For high altitudes and bad weather, navigation systems are very essential for safe aircraft flight. Finally, the surveillance will help the controller ensure the safe separation of the aircraft. Let us look at them one by one in detailed manner. For example, the pilot wishes to fly from Gulbarga to Bangalore. Before flying, the pilot wants to know the weather conditions of the route and the serviceability of navigational facilities along the route, as well as the airport. In order to obtain this information, he must contact the controller. But how? The pilot can talk to the controller by means of the radio communication system. The radio communication link can be established and maintained by air traffic safety electronic personnel so that pilot and controller can talk. This is a simple example of the communications. Now let us see the navigations. Before learning navigation, let us pose a few questions related to aircraft movements. Have you ever wondered how aircraft can fly in the sky? Can a pilot see anything in the open sky? These questions lingering my mind since from childhood. The answer is the navigation system. The pilots fly with the help of the charts which contain the route maps. The charts are the road maps of the sky. They display the airways that connect any two places you need to go. The airways are designed to keep air traffic organized and separated. Airways are defined with ground based transmitters located at strategic points. These land based navigation systems are planned, installed, and maintained by air traffic safety electronics engineers. The third is the surveillance system. The surveillance system will act as an electronic eye to the controller. To understand the functioning of the surveillance system, let us know the controller's work first. The primary role of the controller is to conduct aircraft separation and check whether the aircraft is following the designated route or not. Controllers also help the aircraft transition from the cruise phase of flight to landing. For effective control of the aircraft in the present scenario, where the flights are crowded in the sky, controllers need many tools as well as lot of information. Fortunately, we have a radar system that scans the entire airfield and brings the flight movements within the scope of the radar, which is situated in front of the controller. With this, controllers can regulate the traffic and guide the plane and ultimately bring to the landing. In aviation, the safety is the matter. The aviation is very precise subject. An error of few millimeters or second can make a difference between safety and accidents. Modern aircraft can be flown to be precise figures, speed, heights, profile. The landing and takeoff have to be flown to the exact numbers. They are traveling at nearly 175 feet per second, and a delay of few seconds in the reaction of the pilots can make a difference in the safe conduct of the flight. Whether the skies are especially busy or not is almost irrelevant when it comes to safety. Air traffic controllers have a duty to ensure that from pushback to landing, planes can travel safely in their airspace at all times. And it is the air traffic safety electronics engineer's responsibility to support air traffic controllers in this critical task. Technological advancement and air traffic management modernizations. When coming to the technological advancement, the CNS infrastructure has developed significantly since the early days of the aviations. Earlier, for oceanic flights, the flight engineers would perform navigation manually using paper charts and report the position of the aircraft through voice contact with high frequency radios. With augmented GPS systems, the aircraft automatically report their position and routes using satellite communications. From manual position reporting to the development of radio detection and ranging, that is radar, post World War I, and other terrestrial based systems, surveillance systems have evolved now to provide enhanced surveillance satellite technologies. Due to increasing cost involving maintenance and sustainability, many legacy radar systems are being decommissioned in favor of automatic dependent surveillance broadcast or ADSB. As technology rapidly evolves, enhanced voice communication utilizing satellites is also on the near horizon. Another overall trend is the transition from technology based to a performance based CNS framework in which the technical performance indicators for CNS systems, that is availability, integrity, continuity, are defined for specific operational needs and type of airspace without any system or technology prescription. A few of the main players in the CNS ATM fields are SWIM, that is System Wide Information Management, remote towers, trajectory based operations, big data, cyber security, blockchain, IoT, space based, cloud computing, 5G, and air traffic flow management, virtualizations. In India, we are developing the system wide information management and adopting the remote tower concept, and the air traffic flow management is already operational. We are very interested in adopting a new technology. AA has an MOU with Sweden and an MOU with BEL for the development of an automation system. The AA and ISRO have developed the Gagan system, which is a space-based navigation system in India and assists pilots and airlines for navigation purpose. The system-wide information management enables seamless information access and interchange between all providers and users of ATM information and services. The remote tower concept serves the small airfield and airstrips. The big data is poses two important issues for air traffic engineers, that is data handling and reliability are the two issues. Cybersecurity is an important challenge that we are facing now. It demands a future skill set that air traffic safety electronic engineers need to be acquired, and the air navigation service providers like AA need to look into. Blockchain technology is viewed as a new opportunity, and most of the issues in cybersecurity are being addressed with blockchain technology. We believe firmly that the safest air traffic service depends on the strongest communication, navigation, surveillance, and air traffic management infrastructures. When we are coming to the service volume of India, that is our control region, the AA is providing air traffic service over the entire Indian airspace and adjoining airspace covering 2.8 million square nautical miles, of which 1.04 million square nautical miles are continental and 1.76 million square nautical miles are oceanic. It is the country's responsibility to look after the safe air navigation service in this area. For that, AA provides air navigation service infrastructure, and the air traffic safety engineers in India are on the job providing seamless air traffic services. The role of the air traffic engineers in the national building. Airports are a critical part of the economy of the state in which they are located. They serve as an engine of growth for their local, regional, and national economies. The liberalized aviation environment has attracted many airports as well as many airlines. The employment created by the airports, both directly and indirectly, will have the ratio of 1:4.5, which is not possible in any industry. As for the Civil Aviation Ministry, the Indian aviation sector is expected to handle around 400 million passengers over the next 7 to 10 years. India has become the third largest domestic civil aviation market in the world by 2024. The passenger growth will be 28.9% in the domestic movements in 2021 compared with the 2020 with 71.6 million passengers. All this is because possible thanks to a safe air navigation service in India that in turn the unsung heroes of aviation like the engineers of air traffic safety electronic personals. In conclusion, technological progress and the sustainable growth, that's our approach to the future expansion of civil aviation. Thank you.
You have been listening a special talk on air traffic engineers are pillars of the aviation by Dr. Chilaka Mahesh, Director of Airport Authority of India, Kalaburagi.